Firing angle of a single phase half controlled bridge rectifier. What do you mean by single phase half controlled bridge rectifier? It is nothing but a semi converter. Okay. Now what is the diagram for semi converter? Let us take using thyristors. Okay, this is supply voltage, AC supply voltage we are giving at the input side. This is single phase AC 50 Hertz supply. We have a freewheeling diode on the load side. Okay, this is LOAD load. Output voltage is V0. Okay, now when this freewheeling diode will be in operation, when V0 value is less than 0. What do you mean by that? When it is negative. Okay, if V0 is positive value, that is V0 is greater than 0, no freewheeling action. Okay, you can say this one as no freewheeling action. Okay, now if you see here, single phase half control bridge rectifier supplying an RL load. Okay, that means we have RL load. Okay, and extinction angle beta is less than pi. He has given firing angle alpha. When you draw a waveform for these characteristics, now let us draw a waveform of the output on the output voltage side. Okay, this is input voltage, supply voltage Vs. Similarly, what is the V0 waveform? Let us take this is triggered at alpha in positive, and this is pi plus alpha, and this one is 2 pi plus alpha. Okay, so this is 2 pi, this one is pi. Now when beta is less than pi condition, what does it mean? That this is triggering at this point of time. So input voltage at that instant is equal to Vm sine alpha, which is equal to V0. Now since beta less than pi, I am taking the point at this level. Okay, let us take at this point beta is less than pi, since this is pi. Okay, now this thyristor is going to be turned on only for this instant. Okay, this is T1 and T2. Okay, this value is beta and this one is pi. Similarly, in negative half cycle also we will have conduction like this. Similarly, for the last one, beta less than pi. Okay, so this is the output voltage waveform. If you see there, freewheeling diode is not in conduction. Okay, that means freewheeling action is not at all taking place, since beta value is less than pi for this single phase semi converter. Okay, that means diode will conduct for 0 degrees. Option D is correct answer. A chopper circuit is shown below. Identify its characteristics. Okay, we have two choppers, named it as CH1 and CH2, and two diodes. These diodes are called feedback diodes. Okay, now if chopper 1 and chopper 2 is conducting, if chopper 1 and chopper 2 is conducting, the direction of current is in this way. Okay, this is current I0 which will flow in this direction from supply. Okay, at this point of time, if current is flowing in this way, okay, this is I0, the voltage drop across the load is taken as V0. When CH1 and CH2 are conducting, V0 and I0 are positive. Okay, suppose if you have an RL load, what happens is that this RL load, that is RL load in the sense you have a positive voltage as well as a negative voltage, because it is due to extinction angle beta. Okay, Because of this, what happens is that for this short period of time, the power will be delivered to source. Okay, similarly happens in this chopper also. Okay, at that time when D1 and D2 is conducting, okay, now D1 and D2 is conducting means the direction of current, will be in this fashion. Okay, since diodes are unidirectional, it will allow conduction only in one direction. Okay, that means load current I naught direction is this. Now if load current remains same, I will say when D1 and D2 are conducting, okay, I naught is same, so it is positive value. Okay, but whereas V naught, now V naught, we have to find V naught. Let us draw this circuit again when diodes D1 and D2 are conducting. Okay, now this is load plus minus V naught. Okay, this is D1 and this as D2. Output voltage is, input voltage is plus minus VDC. Now, what is V naught here? Direction of current is same, so it is positive. Now, total voltage VDC is going to appear across this V naught. I can redraw this one as plus minus VDC. Okay, this is a load. This is minus plus V naught. Okay, so I can say V naught as minus VDC. When chopper 1 and 2 are conducting here, when chopper 1 and 2 are conducting, the equivalent circuit can be drawn like this. This is plus VDC. When chopper 1 and 2 are conducting, there will be a load. Again, chopper 2 is conducting this way. So since this is plus and minus V naught, this is VDC. In this case, V naught is equal to plus times of VDC. Since direction of current is same, it is always positive. If you see here options, here I naught is negative in this direction, so this is wrong. Okay, in this option, here also I naught is negative here at this point of time, so this is option also wrong. This operation is not at all correct because there is reverse direction of voltage. Here only one direction of voltage we have. So option A is we are having V naught value positive in this case. This is when CH1, CH2 are conducting. Negative here when diodes D1 and D2 are conducting. Okay, and I naught is always positive. So option A is correct answer. This bridge inverter with RLC load is shown below. Calculate the value of Xc for load commutation. Okay, in inverter there are two types of commutations are possible. One is forced commutation, another one is load commutation. In forced commutation, inductive reactance is more than capacitive reactance, whereas in load commutation, capacitive reactance is more than inductive reactance. What does it mean? That Xc value should be greater than 12 ohms, which is given on the load side of the inverter. Okay, if you see options here, Xc value is greater than 12, that is, he has given option C as 20 ohms. So option C is the correct answer.